Alrighty. This video isn't strictly required, but I thought we would have a little bit of fun. I kind of want to put together something that's along the lines of Lodash or maybe Link that you would see in C#, and kind of use the features that we've been talking about to get that syntax rolling. I think this would be a great exercise for people to take a look at and to really type out the code and understand what's going on, because it combines a lot of the, a handful of the things we've been talking about. There's also a new bit of syntax for iterables, or generators rather, that will be interesting to look at. But mostly, I'm just doing this for fun. I love this sort of stuff, and so feel free to skip it if you don't like fun. So let's go ahead and get started. I'm going to go ahead and go over to my 07 iterators.html and copy and paste it. And I'm going to rename this to 08, I don't know, iterators fun. And I will change my corresponding script file. And then I'll jump over to source scripts. And I'll go ahead and get that over here. Nope, not the HTML. We want the iterator fun. All right. So just went through that fun little ceremony there. Again, I do have my HTTP server running, and I do have my Babel compiler running. So let's go ahead and, just to make sure Visual Studio Code doesn't yell at me, open up a self-invoking function. So what I want to do is, in this video, I kind of want to create a enumerable class, something that would be similar to the IEnumerable in C#, and then I'm going to add some special functions to it. So this is kind of like a library example, something that you might see in a library, but it goes over some interesting development techniques. So let's start with our enumerable class. I am going to go ahead and create a symbol real fast. I'm going to create a underscore generator, and it'll be symbol generator. And then I'll create a class, enumerable. So what is the enumerable class? Well, the enumerable class is simply a class that wraps something that can be enumerated over, be it a computation, such as the Fibonacci sequence, or an object. And his constructor is going to accept a generator. And then I'm going to say this at generator equals generator. So I'm storing that in my as a private field inside of this class. And then just to get this kind of going here, we're going to add a couple more methods to this class. But just to kind of get the example harness going, I'm going to write a nice little symbol iterator here. And you'll notice an interesting bit of logic here. So what I want is, again, enumerable is going to wrap this generator. So we instantiate an enumerable, we pass in a generator, right? But then we want to be able to enumerate over the wrapped generator. So we're creating a enumerable, but notice how I'm combining the two syntaxes. I'm using the asterisk to denote that this function is a generator. So I don't have to write that awful, return iterator done value and all that nonsense. I can use the yield keyword. And then you'll notice I'm using the iterator symbol, meaning it'll be recognized by the JavaScript runtime. And then I'm simply, again, I'm wrapping this generator. So I'm going to say for let item in, or sorry, of this at generator. But okay, this is important. This at generator, I'm expecting to be a generator function. So to loop over it, I need to invoke it. So be very, very careful with adding those parentheses, because we want to invoke that function. And then I'm simply going to say yield item. So far this looks pretty useless. And it kind of is, but we're going to make it useful here in a moment. I'm going to subclass it out, though, because not necessarily all the things I want to loop over are generators. Maybe I want to loop over an object that is iterable. So I'm going to create a subclass, and I'm going to call it object enumerable, and it's going to extend enumerable. And he's going to have a constructor that takes in obj, and he's going to invoke the super constructor. And all the super constructor is going to do is we're going to kind of convert. You can kind of think of it like this. We're kind of converting here a object into a function that returns an enumerable. Or an iterator, sorry. My head's in C# for some reason. So we're converting an object into something that can be invoked, like what you see here on line 11, and then return a iterable object. So let's see how we can use this. Let's say I have a const array. Again, you know, it's 2 a.m. I have no creativity. We're just going to do the first couple integers. And then I'm going to wrap it. I'm going to say, let's just say const enumerable equals new object enumerable array. And then I'm just simply going to say for let item in enumerable console log item. Okay, so far we have successfully wrapped an iterable object, and I can prove it by hopping over into Chrome and loading this page up. Scrolling down to Iterators Fun, and we see that nothing happens because I likely failed miserably somewhere. Oh, I just made a mistake that is actually very common to make, especially when you're getting used to the new for of loops, because they are for of loops. They are not for in loops. Sorry, guys. I know, I'm worst. All right, let's let's refresh that, and we see the integers 1 through 8 being printed. Not exciting. So let's make this a little bit more exciting. Let's actually introduce the ability to wrap our enumerable with operations, very similar to how you would do it in something like link. In fact, let's use the exact same verbiage. Let's create a where function. The idea with the where function is that it's going to accept another function that will filter out items, very similar to the filter method in Lodash. So how are we going to do this? Well, this is going to look really weird, but again, type it out, get familiar with this code. Again, I think this is just a fun example. I love doing this stuff. It's 2 o'clock in the morning, but honestly, if you guys follow through and type this out, hopefully it'll start to give you an intuitive understanding of how this stuff works. So what I'm going to do is I'm going to type out some stuff that'll look really weird. Say old generator, or how about wrapped generator, equals this at generator. And then I'm going to say return new enumerable, and I'm going to pass in a function asterisk that takes no parameters. So that's important. We are passing in a function asterisk. So we're passing in a generator here in the form of an anonymous function. So this is the third way to create a generator. The first way was what we saw in the last video. The second way was what we saw right here with this generator with the asterisk. And the third way is to create an anonymous function with an asterisk. But anyway, so what's our new enumerable? So we're wrapping it in a new instantiation of enumerable. What we're going to do is we're going to loop over the wrapped generator. So I'm going to say for let item of wrapped generator. Now remember, I have to invoke it. I have to invoke it because the wrapped generator is a function, just like what we had to invoke it here. I also have to invoke it here. So these parentheses are significant. Now we're inside of here, we can go ahead and write our logic. Now what's our logic? We want to filter out items that don't match the predicate. So what do? I say if not predicate, item, continue, otherwise yield item. So what I'm saying here is I'm first aliasing out the generator in this object, in the object that where got invoked on. Then I'm instantiating a new enumerable, and I'm passing him in a generator that will wrap the generator from the object that where got invoked on, and apply additional logic. In this case, if not predicate. If the predicate that was passed in does not match this item, continue. Don't return anything. Otherwise, yield it out to whoever invoked this. Okay, so let's see how we can use this. So let's say I'm really interested in computing the given the integers 1 through 8, computing the integers of that set that are less than 5. So instead of saying let item of enumerable, I'm going to say let item of enumerable dot where, passing in item goes into item less than 5. Come back here, refresh, check that out. Only things less than 5 got printed out. So I basically re-implemented a Lodash method, the filter method, but kind of in my own way using the new syntax and iterables. So this should look very familiar to C# developers. And we can do another one. I actually kind of want to do 2 more. I could go crazy and do a bunch of these, but I'll only subject you guys to 2 more of these guys. Let's do select. Select's an important one. Select, if you're familiar with SQL, it's a similar concept. If you're familiar with other functional languages, this would be a map. It's going to have the same exact structure as the where. In fact, it might be prudent to, and maybe as an exercise for you guys, refactor this code out so I don't have to repeat so much for each operation I make. That'd be a fun little thing to do. Anyway, so let's go ahead and say for let item of wrapped generator. And select is different. Select doesn't filter things out, but it applies this function to each one of the items in it. So basically I say yield projection invoked with item. So how can I use this? Well, remember, when I invoked where, I got an enumerable back that wrapped the previous enumerable. When I call select, I'll get another enumerable back. So I can scroll down here, and after I do my dot where, I can just chain on a select. You know, even Visual Studio Code is detecting that this select method exists. And let's say I wanted to return all the items that are less than 5, but I wanted to square them. So I can say item goes into item times item. Coming back into Chrome, I can refresh, and now indeed you see that we get the first 4 squares of integers. Alrighty. So I want to implement one more operation here. It's going to be, let's implement take. So take number. Take, what the take function is going to do is it's going to return X amount of items from the sequence. So if I said take 5, it'll return the first 5 items of whatever source I passed in. So again, we still have to get through all this cruft. Again, a helper method would be really, really, really helpful with this code, but unfortunately we don't have time for that, and I'm probably already boring you guys, so I'll try to keep it short. What I'm going to do here is I'm going to say, it's going to be a little different. I'm going to say const iterator equals wrapped generator. Then I'm going to say let index equals 0. Then I'm going to say, well, I don't know why I did that, because I could simply do for let item of wrapped generator. Remember, invoke it. If you don't invoke it, bad things will happen. Well, actually, I'll just error out saying that it doesn't have a an iterator function on it. Then I'm going to say if index plus plus, I'm using the postfix plus plus on purpose, greater equal to number, then break. Otherwise, yield item. And again, you can see some really, really fun stuff. Again, people who wrote these state machines are way better than I am at computer science. But you can see how it breaks this thing up into this awesome little state machine. It chopped the method up. I think that's so cool. But anyway, jumping down, let's see how we can take advantage of take. One of the most common things that you would take advantage of a function like this would be a sequence that never ends. So let's create a sequence that never ends. I'm going to go ahead and say const fib enumerable equals new enumerable, but I'm going to pass in a generator. And the generator is going to be an unending Fibonacci sequence. So we'll say let last 2 equals 1, let last 1 equals 1, and then we'll say while true. So this is the really cool thing. We're entering an infinite loop here. So you might think, oh, isn't that going to crash your browser? But hold on for a second, and we'll see how that's not the case. So I'll say if our current equals last 2 equals last 1. Oops, there's too many ones there. Last 1 plus equals current, and then yield current. Okay, so how would we use this? Obviously, if I said for let item in fib enumerable console log item, we would get basically what happened in my browser in the last video. It would crash. But if I said something like for fib enumerable, let's do something weird. Let's select the squares of all the Fibonacci numbers. So I goes into I times I. And then let's take the first 15 of them. So again, this is an infinite sequence, but we're doing the dot take on it. And the way we implemented the dot take is it'll only take X amount of items before breaking out of the loop, which will short circuit this while true, this infinite loop right here. Again, if you're interested in how the take works, you can come back here and look at the source code, but or what it compiles into. But let's go ahead and prove that it at least works. And this should also serve as a lesson again. I'm going to leave this in the video, even though it's incredibly embarrassing, that I did for let item in. Whoops. We want to do of. Anyway, now we see it works. So we get the first 15 squares of all the Fibonacci numbers. So yeah, that's pretty much it. We can use this with any sort of thing that's iterable. Like for example, I could say const elements equals new object enumerable, passing in document.query selector all of script. So we'll select all of our script tags. And then I'll say where I goes into i.source index of vendor does not equal -1, and then I can select I goes into i.src, and then I can go ahead and say for let item, and yes, I'm typing in of, I'm not typing it in here, I'm typing in of elements console log item. So now we get a list of all of the scripts we've included that came from the vendor directory. So it's a very powerful thing. I'm sure if it doesn't exist already, there is already a library that'll do all this stuff for you. But kind of playing around with it, getting used to iterators, I think is a great exercise for people. And this is not a beginner example. It's kind of funky the way things look. I know it might look very strange to people, but I encourage people to type it out and try to gain an intuition for how this kind of comes together. But stuff and things. I think that just about wraps up iterators. I'm sure you guys are glad I'm done talking about them, because I don't know if you could tell, but I really like this feature. At this point, I guess we will see you guys in the next video.